That's awesome.
I can indeed. Good morning, everybody.
Morning.
How's everybody doing today? A little tired, maybe? Yeah, I'm a little tired too. It's early, huh? Well, I am Chris Buurma, and I'm a scientist. I am in particular a computational physicist, which means I spend most of my time using computers and physics to see how the world works. There are lots of different kinds of scientists, as you can imagine. A lot of them work in one of two different kinds of places. Either they work at universities and schools and normally are teaching other people and asking deep questions and reading books. There's also the second kind of group, which works for companies, and they try to invent stuff. And I am definitely more of the inventing kind. I love to invent new stuff and try to help the world. When you are a scientist, normally you focus in one of two different kinds of ways. There are the people who focus on building experiments and building robots and creating lasers to kind of probe how the world works. And then there's a bunch of people who sit around thinking and writing equations and doing math and reading books. And they're the kind of people that ask tricky questions. And I am the tricky question kind of scientist. I work with a lot of the other kinds who build the big machines, but I'm the one who asks them the tricky questions. So that's kind of what I do and what I'm doing. I saw your questions that you guys had sent over. A lot of interesting questions about video games, which is awesome because I love video games too. So I think one question you guys asked was, do they use modeling and simulation to make Minecraft? Is that right? So Minecraft is pretty awesome, I'll just say to begin with, because that's a really cool game. But the person who originally made Minecraft made it kind of block shaped instead of making it look like regular people, because he was really good at the physics and the math of understanding how do I take metal and make armor, and how do I take diamonds and make swords? But he wasn't a really good artist. So that's why he made that game. He basically wanted to make a giant simulation where you can kind of mine and craft whatever you wanted, and that's why it's such a cool game. So yes, you can definitely use modeling and simulation in video games. In fact, most video games have a whole chunk dedicated to the modeling part. That's what makes the video games so cool, because they look like reality. So yeah, definitely modeling and simulation is part of cool video games. I actually wanted to share this one story. A couple of years ago, I had the chance to work with one of the people who invented the code. You guys ever watched the Marvel movies with like the Hulk and Iron Man and all that? Okay, so you know how there's some computer graphics inside of there that makes it look super cool? That guy worked with me. He was helping me write the graphics because he wanted to make it look real, like physics equations, right? And I'm like, I know physics equations, but I have no idea how superheroes work. He's like, don't worry, I know how superheroes work. So we worked together to help make that software. It was really fun, actually. So if you guys have any more questions, I would be happy to answer them, or if you have any thoughts. Do you want to call in some students, Gretchen? If I don't know any of their names, so.
Okay, have you even find how small a nanometer?
Oh, so that was a really good question. So nanometers are like ridiculously small, like super duper small, right? So you've got a meter, which most people are about 1 to 2 meters tall, right? Then you have 1,000 times less than that is a millimeter, which is kind of like the little pieces of your hair. And then after that is micrometers, which is like the diameter of little pieces of dust, or even worse than that. And nanometers is 1,000 times worse than that. It's like the spaces between a couple of atoms at a time. So the only way for us to look at that is the same way we use our normal eyes, right? So if I want to see this room that I'm sitting in, I basically have light shoot from the ceiling, it bounces off of stuff, and then my eyes take the light, right? Same exact idea, only super duper duper tiny. So instead I shoot light or electrons straight down at the atoms, it bounces off the atoms and it jiggles them, and then it bounces back, and I have to capture that light. And then I have to sit down and go, okay, I shot out all these photons, it hit some things, it wiggled it, and it came back. Now I know what the atoms look like. It's really cool. A couple friends of mine, which were the experimentalist kind, invented this camera that is so sensitive. It's a scanning electron tunneling microscope. You can actually not only see the atoms one at a time, which is amazing as its own, you can see the spaces between the atoms. Like, it was so crazy. It's like atom, space, 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 atom, space, space. It's like, how can you even do that? So basically, you do it the same way you do it with our normal lives, only everything is so much smaller. Instead of sending like tons and tons of light, I'm sending just a handful of electrons or photons at a time.
I know we have more questions. Somebody asked that very Look how friendly he is.
I'm actually really scary.
I don't know what to ask.
Well, there's no wrong question.
Are you guys curious how he became a part of this field?
Yeah.
Okay. Could you tell us a little bit about how, I don't know if you can see it. Can you tell us a little bit about how you came to be a computational physicist?
Sure. I was always the kid who asked why all the time. And some of my teachers loved it and some of my teachers did not love it. But I always wanted to know how the world works. And so I kept asking tough questions all the time. And whenever I kind of ran out of answers, I would go look for them myself. And that's really what drove me to becoming a physicist in particular, because I kept wanting to know how the world works, right? Where does flavor come from? Why are things colored the way they are? Why am I so tired in the morning? How do I make my broccoli taste like spaghetti? You know, these kinds of questions. As I got deeper and deeper into the theory part, a couple friends of mine suggested I start using computers to solve my problems. And at the time, I had always used computers mostly to play video games, if I'm being honest. And they're like, no, you can program your own video games, which are actually physics simulations. And I was like, wait a minute, I can combine video games with asking why? Perfect solution. And so computational physicist is basically a video gamer who asks why too often. And that is exactly who I am.
I'm sure a lot of y'all can relate to this, right?
I'm gonna break the ice.
Let's hear it.
Where are you right now?
I'm trapped in a basement. You got to get me out of here. No. I'm currently at Battelle in Columbus, Ohio. It's a nonprofit company where we do research to try to help everybody. Our stated goal is to make the inventions for the betterment of mankind. So that's what I'm working on right now.
That's awesome.
Yeah, it's pretty great here. I like it.
We pulled up the Battelle website, so we were able to see some of the things y'all are working on.
Yeah, it's kind of cool. I only started here about a month ago. Before then, I had worked a lot in sensors and solar power. And apparently, these guys have invented CDs, and they invented those barcodes, you know, like when you go to the grocery store, they came up with that stuff. It was pretty crazy. They've invented all kinds of stuff that's helped people. So I'm really looking forward to doing my part and helping them invent cool stuff.
That's awesome. What was the newest thing you made?
Say that again?
What was the newest thing you made?
The newest thing I've made? Oh, let's think here. I guess, okay, so two things. The newest thing I've made at my new job was I wrote a simulation to figure out how heat works inside of plastics. So, you know how plastics are like really cheap, right? You can get plastic all over the place. It's like everything's made out of plastic. Well, it turns out NASA was like, hey, is there any way we could make spaceships out of plastic? Because that would be way cheaper than making them out of all these crazy metals. And we're like, well, sure you can, but the problem is they get like super hot, right? And isn't that going to melt all the plastic? And they're like, oh yeah, what are we going to do about that? So they came to me and said, hey, Chris, you ask tricky questions and you play video games. Can you figure out a way to make plastic survive all that crazy heat? Is there a way to get the heat away from the plastic or something? And I thought about it and I thought about it. And then I wrote a simulation to answer that question. And that was my latest work. The short answer is yes, there's totally ways to do that. You basically take all the atoms inside of plastic. So plastic is kind of cool. It's basically like a big bowl of spaghetti. And all these little noodles are all attached to each other, which is why it's so strong, right? You ever take spaghetti and try to like get it off your fork like it won't come off? It's the same exact idea. So I said, hey, if you want all the heat to come out, all you really need to do is don't cook the spaghetti, right? Make them all long strands. And then the heat will just go straight down the strands. So I'm trying to tell them how to make their plastic spaghetti to be all in a straight line.
Sorry, we had a weird recording thing. That was cool. We're going to re-record some more. Hold on.
All right, no worries.
We hit our free limit on that recording, so
Oh,
we're gonna
okay.
just start it.
No worries. I've got a
Good
little recording
morning.
here.
Oh, wait, sorry. Okay.
Oh, we can hear you.
Wait. That's terrible. Okay. All better.
Cool.
I don't know, just
Okay. What do y'all think about that with the spaghetti and the trying to solve a problem?
That's like a really good example.
It was a good analogy.
3, 2, 1.
Get out of here, creepy.
There we go. We're recording. Okay.
What does nanotechnology do?
Okay, so you know how like in the Marvel series, every time someone says quantum and it's basically magic? They're not far from the truth. Nanotechnology is basically saying magic and having it totally work. So, all right. The world is made out of atoms, right? Like they're all over the place. It's what makes everything. The problem with atoms is that there's only like 50 different kinds of atoms that you can basically put into a bucket. Otherwise, they get too hot and they explode and all these crazy things. So 50 different kinds of Legos isn't enough to build everything we can imagine. Nanotechnology is a way for us to invent our own atoms, which is kind of awesome. Basically, you take clusters of normal atoms and you put them in special shapes, and then these little bundles of atoms all work together like custom atoms. And so nanotechnology basically turns us into wizards where we can make up any atom we want with any properties we want, glue them together however we want, and invent all kinds of stuff that never existed before. So like the screens that you guys are probably watching this on, or your laptop screens for your Chromebooks, they're made out of nanotechnology because most of the screens are based on these quantum dots now. Nanotechnology is inside of our cell phones and electronics. It's helping power our cities with our power grids. It's kind of crazy. The era of nanotech for the last like 30 years has really issued in this era of sure, we can do that. Just give me enough atoms and I'll put it together for you.
You're a wizard, Buurma.
A wizard Legos, right? Go ahead.
I'm kidding. So in the movie Ant-Man,
Say that again?
have you like helped with anything? With like, did any like nanoscientists help because like he has to shrink down to like the nano?
Oh, yeah. So the fun part of those movies is that they normally will hire a scientist to answer questions when they make the movie. And the directors have to choose between making it scientific on purpose and making it kind of a more fun story. And so they kind of smash the two together. So a lot of times they have real science in there. Like Tony Stark has those computer screens all over the place, right? And he's trying to invent new stuff and putting things together. That's actually pretty real. That's similar to what I do. But then other parts are not very real. Like when Ant-Man decided to go back in time and shrank himself. Like that's definitely not like a thing. That's just a really cool story. And so basically when you see those movies, A, have fun because that's what they're made for. And B, ask questions because sometimes that stuff is totally real and sometimes it's mostly for a cool story. So some of that stuff is pretty real. Like Bruce Banner did this one part, remember in the first Avengers movie where they were trying to find Loki, and he says, we need to take every cell phone and turn them into spectrometers and look for the gamma peak. Like that's like a real thing actually. Like you could really do that. You could look all over the country everywhere at once for a certain type of chemical bouncing off of itself and figuring out what the world is made out of. So that's like a real thing, which is pretty cool. That's when I was a kid too, and I used to watch a lot of science fiction. It was fun getting those kinds of questions because they'd be like, reverse the polarity on the photon beam. And I'm like, do photons have polarity?
All right, more questions. I know you have them. Go ahead.
What was your favorite like thing to do as in like a question that somebody's like asked?
What was my favorite question that somebody asked?
Kind of, yeah. Like when like did like the plastic heat thing, like what was like one of your favorite things that like
Oh, okay. Let me think here. What was my favorite question to answer? Oh, okay, I know this one. So for quite a while, I was working on artificial intelligence, which is kind of a way of making computers think like we do, right? You probably heard about AI before. One of the most fun questions that I was given was, can you teach an AI to do physics? And I'm like, man, wouldn't that be cool? I can like clone myself and talk to myself about physics and then just have this artificial brain helping me all day in my laboratory. Wouldn't that be awesome? And I'm like, I don't know, but I'm going to go find out. And so I wrote a whole bunch of code trying to teach the AI to learn physics. And then I talked to other scientists, and they're like, oh, yeah, we've been working on that problem for a few years. Come read our papers. Come read our books. And I'm like, oh, my gosh, you wrote a whole book on this? So that was really fun to learn about and to try to ask that question. The short answer to this question is they haven't figured it out yet, but we're not sure if they can do it or not. They actually did teach an AI and a robot to figure out Newton's laws, which are about 300 years old, 400 years old. So this AI learned all of these old physics equations, no problem, which was like, wow, that's cool. We can teach a robot to learn old physics. I wonder if we can teach a robot to learn new physics. So that's kind of where they are right now. Wouldn't it be cool if we could just clone a scientist and you could put them in every classroom? And so if you guys have tricky questions, you've got a little synthetic brain like, hey, you got tricky questions? I've got tricky answers.
That would be awesome.
Wouldn't it?
You don't understand? Oh, because you haven't had life science yet. Well, ask that question. He knows the answer.
I don't know all the answers, but I try to learn everything I can.
You know this answer. Go ahead and ask.
But doesn't cloning, like, it just creates something that looks the same at what you just cloned, but it doesn't have the same personality or thinking as the
Yes. So I guess there are two kinds of clones. What I was talking about is a computer clone, where I just take like a piece of paper with all the words written on it, and I just copy the words to another piece of paper, which is more like computer cloning. In biological cloning, like if you took a mouse and you wanted to make another mouse that looked exactly like it, you would pull off its DNA and you'd mix it together and then make a little baby mouse and put it inside of another mouse, and that baby mouse would grow up and be just like the first one. But it's definitely not the first one. It's not like a copy machine, right? That new baby mouse would have to grow up, and when it grew up, it would be the same as the old mouse was, right? So yes, you're right. Cloning isn't like a copy paste. It's not like a copy machine. But for computers, it's more like a copy machine, right? You can just like copy. Like you ever take a photo with your phone, or your parents took a photo of you and they decided to copy it to their friends? Just like that.
Does that answer your question? Yeah. Awesome. Oh, yes, go ahead.
So when you're making something, how do you know if it like needs to be better?
Sorry, I couldn't hear you very well.
When you're making something, or when you're something, how do you know it could be better?
I missed the very last part. When I'm making something, how do I know that what?
It could be better.
Oh, that it's better? Oh, okay. So this is actually, if I understood your question right, if I'm making something and inventing it, how do I know that it's better when I'm done, right? This is actually one of the most important questions you can ask as a scientist. I think you're going to be one. Because you have to kind of balance wonder with skepticism. It's a very delicate balance. If you're too skeptical, you're just kind of like, nothing will ever work all the time. And if you're too wondrous and you never ask tough questions, you're like, the world is magic. I've got giant fluffy unicorns. And you're like, all right, calm it down. It's somewhere in between. So if I invent something really cool and I need to know if it works, I'll do two things. One, I sit on paper and I do all the math, right? I'm like, all right, if I'm going to make custom atoms that taste like turkey but they give you all the health of broccoli, let's make sure that that is even possible. And so I do all the math and I do the calculations and I go to my computer and I'm like, calculate turkey flavored broccoli, go. And when I'm all done, I'm like, all right, where's my buddies who make science experiments? You with the lasers over there. Come over here. Can you make this atom that I wrote on my computer? Is that a real thing? Like, can you go to the laboratory and try to put it together for me? And they're like, you know what? I bet I can, because they almost always say that. It's kind of crazy. These guys can invent anything. So they normally go do these experiments. They invent the thing, and then they test it. And then they get that first ever turkey-flavored broccoli, and they take a bite, and they're like, you know what? It tastes like bad turkey-flavored broccoli. Is there a way you can do this better? And so part of the scientific method is having a hypothesis, an idea. Can I make broccoli taste different? And then having a prediction. Yes, I can. That was all the homework I did. And then I test it. And so I go to my friends and I'm like, can you test this weird broccoli idea? And then I confirm my hypothesis, totally can make it. Or I deny my hypothesis, nope, try again. And that's just totally part of how my job works. If you don't do that
That's
last
so-
part and find out, you're kind of just doing math because it's fun and not actually figuring out how the world works.
That's so neat. I gotta stop our recording again, but you just keep on going.
No worries.
Okay, so we have a question back there. Go ahead, Jordan.
Have you ever done anything for the military?
Yes, actually. So when I first started working in research, you discover that the military has like a ton of money, especially in the United States. And so it's kind of cool. Different branches of the military work on different parts of the problems. Like the Navy was really interested in solar power and climate change because they're like, dude, we're out on boats all the time. We need to know if there's going to be more ocean or less ocean. And I don't have a gas station in miles around. We need solar power. And other groups like the Army are more interested in sensors because they're like, I need to make sure that no one's attacking us. And so they come to us and they say, hey, can you invent this cool thing that does this thing for the military? And I'm like, well, sure we can. Let's try it. I've always made it a point not to try to make weapons technology and kind of mean stuff that hurts other people. Some people do that, and that's fine for them. But I always like making stuff that kind of prevents it. I always wondered, can I make a shield so that nobody can get shot anymore? Or can I make your clothes like soft and comfortable but so strong that it's like wearing armor all the time? Wouldn't that be cool? So like if like, you know, you're walking down the street and you're wearing your clothes and you get hit by a car, instead of being like in the hospital, you would just like have ruffles on your clothes like, oh, apparently that car hit got blocked by my pocket. That's comfortable. So the military loves that idea, right? They're like, if we could put clothes on all of our soldiers that worked like armor, then we would just totally give that to everybody. And then our soldiers would be like immune from getting hurt all the time. So yeah, I've done military projects. I like to do the ones that help protect our soldiers. Actually, one more quick story before I let you ask another question. One of the more fun projects I did for the military was a number of years ago, there were some people making weapons that use chemicals and kind of poison everybody at the same time. They were like being big jerks. So I invented this sensor system that can detect those chemicals like all down the street. So the idea was you could like fly by with an aircraft and then look down and see if there's any chemical weapons hidden anywhere automatically with this little sensor system.
That's amazing.
Yeah, it was pretty fun.
Really smart.
It is really smart.
Very smart.
He's brilliant. What can we say, right?
I just asked a lot of questions. I'm not smart.
So, I think you were next. Go ahead.
So, I think back onto like the clothing armor, it could kind of be like ebook, how like it's soft when you just like hold it in your hand while on impact, it like harder and stops.
Yep.
So that,
That's totally a thing. So actually, one of the very first... Oh, sorry, you were saying?
so ebook would be a good demonstration for that.
Yeah, so the very first ones they invented did exactly that. So they were nice and soft, and then they had this I think it's called non-Newtonian mechanics. So when you push against them, that pushing energy tells all the atoms, oh my gosh, someone's pushing us. Everybody stand in a straight line. And all the atoms would get really straight, which worked really well at what they call dispersing the energy. It's kind of like the difference of somebody poking you with a finger or somebody pushing you with their hand. It's the same amount of push, but in a different place, so it doesn't hurt as much. The problem they had was that the bullets were still so strong that instead of getting like shot, you'd get pushed over all the time. And they're like, okay, that's pretty cool. I love that. But can we make it better? Can you make it so instead of getting pushed over, I just feel like somebody gave me a hug? Because that sounds way better. Like, can you imagine if people just shot you with bullets and it just like felt like hugs all the time? That's what they came to me for. Like, can you make it actually even better than this? And we're like, oh, no. The atoms are already a straight line. I mean, you can't get more straight than a straight line. And so I had to run some simulations to answer that question. So basically, if you grow up and you want to ask these same questions, we need more scientists doing that. It would be really cool to come up with more protection technologies to keep us all safer from people trying to hurt us. And it's the kind of technology you can't really go wrong, right? Like, oh no, everyone is immune to bullets. What have we done? Wait, that's good.
It's a good question. Yes.
Is there a way for us to do solar panels that are so strong that we can absorb the sun's rays from the moon? Since the sun bounces off the moon to make it shine at night?
So you totally can do that. And it's really smart that you know that the moon actually bounces light off the sun. That's awesome. So solar panels that we have today actually do work on the moonlight. So when you have a full moon, the solar panels will actually totally work. The weird part about the moon being this giant mirror in the sky for the sun is that it's kind of bad at it, and most of the light isn't kind of focused towards you. It just kind of bounces in all directions at once. So the sun's like over here, and the moon's over here, and the earth is like my head or something. And the light comes in and it bounces off, but instead of coming in a straight line, it's like boom, all directions at the same time. And you're like, what? Where are you going? You're supposed to go to the earth. And so what happens is you lose like 10,000 times the power because most of that light never makes it back to the planet. So the solar panels that work at night, they still work, but they're 10,000 times not as good. So a lot of people don't worry about it. It was actually kind of cool. So I used to work on solar power actually. One of my friends had the same problem. He's like, how do we make solar panels work at night? Because they totally don't, because there's like no sun. And they started thinking, well, maybe we can work on starlight, but then there wasn't enough stars. And then they had this idea. All we have to do is in noon, when the sun is up and it's so hot, we have so much electricity we can't even use it. What do we do with it? It's actually kind of cool. They take a giant boulder and they just drag it up a pit. And they're like, what are you doing with this giant boulder? And they're like, wait for it, wait for it. And then when the sun goes down and everybody wants to go home and watch their TVs and they turn on their power, the boulder's just like, oh, I'm going to fall back down now. And as the boulder falls back down, it turns a little engine and powers everybody's houses. And so we take all the extra energy that we would have wasted and we just haul up this big rock. And when everybody wants the energy back, we just let the rock fall back down. And then all day we get power from solar. I thought that was a pretty clever idea.
How does how do solar panels work? Is it like absorbing the energy kind of like a sponge or?
Oh, it's actually super cool. So there's two kinds of solar panels. I'll talk about photovoltaic ones, which are my favorite kind. So light is made out of these little groups of energy called quanta or photons, right? So you kind of imagine it like a giant bucket of marbles. So every time you get sunlight, it's like someone's pouring a bucket of marbles on top of you all the time. Solar panels take the energy of those little marbles, and when it hits the crystal, so the solar panels are only made out of like a crystal with a bunch of atoms in like a grid, it hits that spot, and the crystals kind of like vibrate, right? The energy of that whole space goes up. And when the energy goes up, it shoots all these little electrons free. So since everything's made out of atoms, you have these big, hard, chunky parts called the ions. And these electrons are kind of everywhere else like a goo, right? It's almost like a Jell-O pudding. So when the marbles fall into the Jell-O pudding, all the goo splashes out. And then we collect all that splashing goo, and that's the electricity that we capture. So you kind of imagine it like the sun has this huge army of marbles falling at us. Then we have this like plate with a bunch of marbles in it, or a bunch of like rocks in it with goo everywhere. And when the marbles hit the goo splashes up, and then we capture it all. So the solar panels work as long as the sun is pouring marbles on us, then we get all this goo. And that's kind of why the moon thing doesn't work, right? Because it kind of does work, but the marbles are so small, or basically there's so few of the marbles, it doesn't work very well, right? Or like the starlights, the same idea. You're only getting like a handful of marbles, and so not a whole lot of goo comes out, and so you really just don't get very much electricity. That's why they don't work inside either, right? Because there's definitely lights in here, and there's lights in your classroom, but there's not a whole lot of them, right? If you were to grab them all into a handful, versus when you walk outside, you get like huge truckfuls of sun. So that's why they're outside all the time.
What was your favorite science subject that you worked on?
My favorite science subject. Oh, let's see. I guess. So when I went to college, my favorite subject was quantum mechanics, which sounds weird because everybody hates quantum mechanics because it's so weird. Like, oh yeah, things exist in two places at once, and cats are inside of boxes, and they may or may not be poisoned. And you're like, what are you talking about? But I always thought it was kind of cool that you can make stuff work in ways you would have never predicted otherwise. And so I always really enjoyed doing the math of all this weird like quantum mechanics. So before I went into college and I learned all that crazy stuff, one of my favorite classes was chemistry, because they were explaining how you pour like a red liquid and a blue liquid together, and you get like a green liquid, and then it turns into a solid, and all these chunks come out. Have you ever made elephant's toothpaste before? Oh my gosh, you've done that?
I know what it is. I
Okay.
want to make it.
If you've seen it on
But then
YouTube,
it's gonna ruin our backyard, and it's gonna go.
right? Right? Wasn't that cool? Right?
Toothpaste cannon.
It's like a toothpaste cannon, exactly. And that was chemistry. I learned that in my chemistry class, and I'm like, wait a minute, you can make toothpaste cannons? That sounds amazing. How does that work? And so it was one of my favorite classes, trying to figure out how all the atoms work.
Actually used as toothpaste? No. Okay.
I think you would not like the flavor.
Why is it called elephant toothpaste?
It looks like toothpaste made for giant elephants.
Elephants are so large and it's like, it looks like
Yep, so that was probably my most fun thing there.
Out of all the companies you've worked with, which one has been
Sorry, I couldn't hear you very well.
Yeah, I don't think you could hear. It's project.
out of all the companies you've worked with, which one has been your favorite?
So of all the things I work on, which one has the least, what?
Out of all the companies you've worked with, which one has been your favorite?
Which has been my favorite company that I've worked with? Man, that's a good question. I've worked for 3 different companies since I graduated school. My first one was a solar company called First Solar, and we worked on making solar power, as you can imagine. The second company I worked on was called EPIR, and for a while we kept working on solar power too, and then we switched into sensors, mostly helping the military to keep the soldiers safe. And then after that I started here at Battelle, and I've been here for about a month. So I guess I liked each of them for different reasons. First Solar was really fun because I've always had a passion for energy. I always feel like the way we harness energy as a people defines what we can do, right? If you want to make a spaceship, how are you going to fly that spaceship, right? You want to make Amazon deliver all your packages for free? Well, how are they going to gas up those helicopters? So I always liked that. When I was at EPIR, it was a really good experience for me to learn and be surrounded with other scientists and ask tricky questions, and they would teach me how to use the computer to answer tough questions. And so it was kind of fun inventing technologies that could help protect our soldiers while at the same time learning a lot. I learned so much there. Here at Battelle, it's been really fun because our mission is to help everybody at once. How can I help the world as much as possible with inventions? And so I'm really eager to do my part to help them here. So I guess I liked each of them for different reasons.
Have you ever helped make a game?
Help make a what?
A game.
A game. So yes, I totally have. So in my spare time at home, when I'm not hanging out with the kids, I've been making a video game about robots battling each other. And the robot battle video game, you're supposed to teach them with artificial intelligence how to battle each other, which has been really fun. It's basically a giant physics simulation, just so you know. But it's cool because the robots have all these different like lasers and they fly around. So yeah, making video games is kind of fun. The difference between that and the science work is in the science work, normally you're asking tricky questions like, how does this work? How does this work? In video games, it's much more like, how do I make people have fun, right? How do I make people enjoy the game so they want to play it more? And so they have different goals, but the same sort of tools at disposal. So I like making video games because you can share them with your friends, and you can make cool games that only you really could think of. And really, it takes a lot less work than you'd think to make a video game. There's a lot of free software that lets you do it really fast. Like there's a game called Scratch that lets you create your own video games. There's software called Godot that lets you make your own video games. And, you know, some people can make them in like 2 days, a whole video game from scratch. My first video game took me like 2 or 3 months to make. But, yeah, they're fun.
How many different things have you worked on?
Oh my gosh, how many things have I worked on? Lots of things. So in my career as a inventor scientist, normally you get funding contracts from different people who basically give you a bunch of money to try to invent something, right? And those little contracts work for about between 6 months and 2 years, depending which they are. And so you can imagine over my last like 10 years, I've worked on like 30 or 40 different projects. So, because normally you do like 2 or 3 of them at the same time, and then you also keep changing them like twice a year. So I've worked on sensor systems for doctors to triage burns, like if you get burned at the school. I've helped scientists work on solar power. I worked on satellite systems for NASA. I worked on engines for the spaceship. I worked on that sensor system to help detect chemical weapons. That was a neat project. I worked on artificial intelligence to see through snow and dust. That was pretty cool. I wrote this software to put onto an airplane or a satellite, so when you fly over the planet, you can detect how the climate is changing over time. I made that one project the other day about trying to make plastics work for spaceships, so make them hotter. Gosh, I've worked on all kinds of different projects. Whenever you've got a tricky question to ask her, a lot of people come by me and they're like, hey, I've got this project and I've got these tricky questions. What do you think? And so I end up getting involved in a lot of different stuff.
Going back to the solar panel thing, is there a way for us to use cars and solar panels and batteries, making it so at night, even though it takes a long time, the cars can charge up the solar power to the battery and still use the sun solar power more?
Absolutely. Absolutely, you can do that. In fact, some people have tried doing this already. Tesla was very famous for this. They put a solar panel on the roof to try to charge the battery. So here's where this modeling and simulation comes in really handy. So if you put a solar panel on the roof of the car, every square meter of space, so a square meter is kind of like, okay, so see right behind you guys that calendar with all those numbers on it? That's about a square meter, right? So imagine you put that on your roof. Every square meter, you get a kilowatt of power. So a kilowatt is about the amount of energy it takes to run the lights in this room for like half a day or maybe a day, right? So if I want to drive a car and I leave it outside in the sun, I can capture all this energy to run my lights and drive my car. But if I let it sit in the sun for, let's say, 8 hours while I'm at school, and then I want to drive home for 10 minutes, no problem. But if I want to leave out in the sun for 8 hours, and then I want to drive to my neighbor's house across the city, and it takes 2 hours to get there, I'm going to run out of electricity. So we have 2 ways to fix this problem. Number one, is there a way to make the car use less energy? Because, man, it's really guzzling the electricity. Can we make it more efficient? Can we make it out of cheaper plastics, or can we make the engine more clever? And then answer number 2, can I get more energy out of that calendar space of sunlight? Can I get it more efficient? And those are the 2 parts of the problem that people are working on right now. A lot of people have this really clever idea, which I really liked, is, we don't have to put the panels on the cars. We have all these buildings with roofs everywhere, and they're just kind of like a waste of space. Can we just put solar panels on like everybody's roofs, and then whenever you park your car there, you just get like free electricity? And so some people were working on that part of the problem. Can we just use up all this wasted calendar space, and then when people drive their cars around, just wherever you go, you just get the electricity from the sun in that area, right? Wouldn't that make sense? So that's what people are working on, and to make our cars run essentially for free, right? Wouldn't that be cool?
It's really cool breaking it down into the problem into pieces. And
It's what I do all day.
yeah. Like a good life skill, no matter what field you go into.
And honestly, yeah, like if you guys want to study science and decide not to become scientists because you want to become doctors or accountants, that's fine. Learning how to ask these kinds of tricky questions will help you no matter what you do. I always felt everybody should try to be a scientist, and not everybody should, has to be a scientist, right? You should always try a little bit just so you get a taste of how it works.
I agree.
Have you worked in any like medical things to help like medics or things like that?
Yes, actually. So one of my fun projects was the burn triage project and this insulin project. So I'll talk about the burn one a little bit. The insulin one is brand new, and I'm very new at it, so I don't know a lot about it. So the problem was, if you have someone who gets hurt in like a building fire, or if there's an accident and they like accidentally fall on top of the stove and they burn their hand or something, doctors have a real hard time right now figuring out if you need to go home with a bandage or do you need surgery right now, or you're going to get really hurt? And the doctors really can't decide what to do. They're like, gosh, do we need to do surgery, or do we send them home? I don't know what to do. And so most of the time when they don't know what to do, they're like, you know what, just do the surgery 100% of the time, And then all these people have to go to surgery all the time when they maybe don't have to. So I invented this sensor that works on your cell phone, and you just plug it into the bottom, and it uses an artificial intelligence. So you just kind of pass the camera of the cell phone over top of the burn, and it takes all the pictures and the heat, and it unwraps it three-dimensionally, and then it glues it back together three-dimensionally, and then it says, okay, if this is the burn, and I've talked to all these other doctors before, this is how burns, progress over time, and it will tell you with the artificial intelligence, this definitely needs surgery, or it will say, put a bandage on it, put this chemical on it, you'll feel better in the morning. And this helps people in two situations. One, places where there just aren't any surgeons, right? What if you're in Uganda, or what if you're in Israel, and there's no doctors around because you're too far away? Then you can use this little sensor that's really cheap, and it says, oh, don't worry about it. Or it says, oh my gosh, definitely worry about it. Drive to the nearest doctor. And then situation number two is if you have a whole bunch of patients all at the same time, right? Something awful happens, like that, the hurricane in Puerto Rico, right? Where all these buildings fell over and there was fires and stuff. You have to treat all these people as fast as you can. Well, you get 10 people with cell phones to walk around, and the doctors know exactly who needs the most help. So that was kind of a fun project because I wanted to be able to help people as quick as I can. And I'm not a doctor, right? I don't know how to help people. I get a cold and I'm just like, I guess I drink water? I don't know. But I can teach an artificial intelligence to try to mimic some of what doctors know.
Is Baymax from Big Hero 6 physically possible?
Oh my gosh, I love that movie. So the short answer is yes. It's very possible. So you know how I said in some movies, some things are like kind of for story parts and some parts are very real? The Baymax part is like super real. We definitely have titanium alloys. We definitely have carbon nanofibers. His eyes, the sensors that figure out if you're sick or not, those are real things. I actually helped invent some of those. The big piece with Big Hero 6 that's missing is the artificial intelligence is not like it is in the movie. And we're working on that like super hard. But all of the other parts, like the arms that move up and down and the big poofy part, like the robot himself is totally real. Now, being able to fly around and shoot lasers, that's probably less real. That's mostly for a cool story. But the robot himself, very real. All we need to do is figure out how to get all those smarts in there. Remember in the very beginning of the movie where the character says, this has got all of Baymax's smarts in it. He puts the chip in. That's the part we haven't invented yet.
Do y'all have any science and engineering fair questions?
How did they invent the 3D printer?
How does what is a 3D printer?
How did they invent it?
Oh, how did they invent it? Gosh, I actually don't know. I know that for a long time people were working on different types of making plastics, and a long time ago they had kind of 3D printers, but they were basically the size of whole offices and whole rooms. So like if you're a company and you're trying to make toy soldiers or you're trying to make, Baymax dolls, you would have this giant machine and you would heat up the plastic into like a goo, and then you'd pour the goo into a shape and then it would solidify, right? Well, then they invented this special kind of plastic called ABS, which you squirt it out like liquid, and then right as it touches something, it solidifies. And so you're like, oh, that's cool. I can basically make a little pen that I can draw with. And somebody thought down and said, could I build a robot to just use that pen to draw things in 3 dimensions? And the first robots were basically versions of that whole office building. And so they kept making them smaller and smaller and smaller. So I don't know if that's like exactly how they did it, but my guess is that's how they did it. They probably took the office size ones and shrank it down and then used the little printer part. 3D printers are actually pretty awesome because, especially for me, because I like to sit around and think up stuff, and I don't want to run the experiments because I don't know how to do it. So if I can plug into this robot that makes them for me, I'm like, here's a plastic that'll work for a spaceship. Click, print, wait for the printer. Ha-ha, spaceship plastic. And then I can go test it right away, right? So 3D printers are pretty awesome. They actually sent some up to the International Space Station so they can print parts. They're like, oh no, we're out of screws and we're totally in space. There's no screw stores anywhere, and they can just print their own screws.
Any other questions? Go ahead.
Do you have any pets?
I do. So I have a cat named Professor Snoopy. He's a professor of catology. And he's a giant orange Maine Coon cat, and that cat loves tuna fish, let me tell you. If I'm eating any sort of tuna fish, he climbs up on my lap and he's like, give me that tuna fish. I have a dog named Nefret, and she's a really good dog, except for she likes to run outside and take herself on walks, which is not normally okay. I have a couple of fish as well, which are really fun. I actually have always really enjoyed pets. When I was a kid, in junior high, I actually had a pet snake and a pet spider and pet mice. I always like pets.
That's a good question. And I hate to cut you all off, but the bell's about to ring.
I know.
Oh, well. Well, kids, it's been great talking to you guys.
Thank you so much. We appreciate it.
Yeah,
That was so
thank
much
you.
fun.
Yeah, it was.
Y'all